This is question 2 from the Describe Questions practice sheet for the pneumatics section of Mechanisms and Control. So we're given a circuit where we've got a pneumatic circuit being used to process components on a production line. And our approach to this will be the same as for other questions. We're going to identify, first of all, where air can be supplied to this circuit and what it's currently doing, and then what we as a user can actually do. And from that, that will give us our path to describe the operation of the circuit. So to begin with, we have potential air supply in valve 3. It's not going anywhere just now, and the same in valve 1. Until these valves are actuated and change state, that air is not doing anything. We have the air supply currently flowing through valve 4. It's flowing in here, and it's currently causing piston and cylinder A to be instroked, and the piston and cylinder B to be instroked as well. So we can see that as where the air supply is currently going. And there's also an air supply up in valve 5 here. That too is going nowhere. So the status quo, the starting point for this circuit, is that there is an air supply flowing through valve 4, causing the two cylinders to be in the in-stroked position, and that's our starting point. And if you can kind of, without even talking about pneumatics, I think the idea here is from the picture at the top is that the two cylinders will outstroke together. It looks like it's sort of sorting this stack of whatever these things are on the conveyor belt, and then they're withdrawing again till the next stack to come along, and then they're going in again. So we're going to have a some kind of repeating process. We determined if it's automatic or semi-automatic once we see, or maybe it's just going to be we have to manually actuate it every time. That's the things to look out for as well. This is our starting point. Now, what can we as the user do? Well, we can do two things. We can send a signal from the microcontroller, that would deal with valve 1, or we can push the push button on valve 3. And because there's a shuttle valve here at valve 2, these are both going to have the same effect. They're both going to allow air to travel up to valve 4 as a signal. So our starting point would be if a signal is sent from the microcontroller to actuate C2 valve 1 and cause it to change state, or, and I'm just writing this in here like this to make it clear, obviously a normal or your own work, or push button on 3.2 valve 3. I'll circle these because this is the number of the valve rather than anything. 3.2 valve 3, push button 3.2 valve 3 is pressed, causing it to actuate and change state. Then a signal will be sent to 5.2 valve number 4. This is what our starting point is. So if we have the microcontroller signal being sent, this valve 1 will change state, allowing air to flow through. And if it does, then the air signal coming here through shuttle valve 2, ball will slide across and air will be supplied to valve 4. Or, if that doesn't happen, instead, if we press the push button on valve 3, air will flow through it. send a signal going through valve 2 and going up to valve 4. Now you can't explicitly say it'll go through the shuttle valve and this will happen, but this is implied with the big or, I've written here, normal size or in lowercase will be fine, but we've already acknowledged the role of valve 2 by saying that either one of these could do it. So we could say, if you wanted to be extra cautious, because they both feed into a shuttle valve, so either the supply from 1 or 3 can send the signal, but this would be absolutely fine. Answer like this. So this is what's happening in the first part. Either of those two valves can be actuated, causing them to change state, and when they do change state, an air signal will be sent to valve 4. This is providing pilot air, so we can say that this provides pilot air to actuate. I've already established it's a 5-2 valve, so I'm just going to call it valve 4 now. Valve 4 causing it to change state. Now this is the bit where we have to just be a little bit careful about what's happening, but as long as we are, we'll see exactly what's going on here. I'm going to just rub out this just now because this is all going to change. So when valve 4 changes state, that means that instead of having this box here connected up, it's going to be this box here instead. And with a bit of imagination, you can see that it's going to be the air coming through to the right-hand side, and the right-hand side connects with this bit here instead. So what's happening is the air is now going to flow along these lines, to the other end of the cylinders, causing it to change state. That's what we said, allowing air to be supplied to the opposite. Now, we won't call it left or right because the left of one, it's out of the other, so we'll call it the opposite end of the cylinders because it's currently being supplied in the inner side, if you like, to keep this pistons in stroke, the opposite end of the cylinders, which will cause the pistons to outstroke. So this is what's going to happen. Air is going to come in here and it's going to push these pistons out the way. So what's going to happen is our pistons are going to come out, do one on the right first, and come out to here, and the one on the left is going to come out, but it's going to connect with the roller trip valve on valve 5. So what we would say here, when the left hand, when the left hand piston outstrokes, it will actuate valve 5 by triggering the roller trip valve. This causes valve 5 to change state. And so now that air supply up at valve 5, go back over here and look at this. Now that air supply up at valve 5 can flow through. So we're going to have air being supplied through here, so it comes through, this is going to send a signal down here back to valve 4. Valve 4 will switch over. The air will be supplied in the other end of the pistons again, causing the pistons to in-stroke. And valve 5 will then return to its off state. So we can say all of that. I mean, it's probably enough to say that it sends a signal to valve 4, causing it to actuate and change state, supplying air to the pistons, causing them to in-stroke, and that's how we'll end this here. So we can say this allows a signal to be sent to actuate valve 4, causing the direction of air to the cylinders, as I say, to be reversed, causing them to in-stroke. So let's have a look at what's going to happen. I mean, we've got the written answer here. You can go back to the video to see this, but I'll move that back. In essence, what happens here is either the signal comes from the microcontroller or we press the button in valve 3, and either of those will send air up to valve 4. When air is sent to valve 4 from the right hand side, it's going to switch the supply of air from pushing the pistons in the cylinders to pushing them out. And the pistons will push out into the setup of current like I drawn in the diagram. But when that left-hand piston pushes out, it's going to hit that little roller trip that's hanging down. And when it does that, air will start flowing through valve 5, and it will come back in on the left-hand side of valve 4, switching it back over so that instead, mark this on just in purple as a kind of final point, air will then flow back in this way and cause these to in-stroke again. And then we'll be back to the beginning. So it's not automatic or semi-automatic. We'll always have to send the signal back in, but of course it could be made automatic if it's an automatic signal from the microcontroller, but it's not automatic due to the pneumatics in the system themselves. So I'll take those purple marks off. I think I'll save this whiteboard after this video, and that's our answer to question 2. So again, I've probably written a little bit more than would be absolutely required, but if you include all this level of detail, you can't go wrong in a TMA question.